We're at the cabin 5-day forecast. This is a photo at mile 17 on the Teclanica River near Nenana. This is where my weather station is. We really love it out here in the wilderness. It's a beautiful sunset from last week that we took. Satellites give you a better look at what the weather is going to be. We are using 3 satellite images for this investigation. They are Channel 1 is visible, Channel 4 is thermal, Channel 3 is water vapor. At many locations on the map, a standard plotting code indicates wind direction, speed, air temperature, dew point, barometric pressure, and its changes during the preceding hours and the amount and type of clouds, the weather type, including restrictions to visibility and the amount and type of precipitation. Here is a weather map that shows contour lines like a topography map which show with high mountains and low valleys. The pink areas show rain and snow, light blue shows snow, green shows areas of rain showers, blue shows cold fronts, and the red line shows heat. This seems to have a cold front moving through South Alaska. The cold is going south and some mixed areas moving north. There is a warm front moving northeast along the Pacific coast. This week has been fairly nice with a lot of sun, and we are really loving that. I love this wind map. When I'm at the cabin, it's hard to tell where the wind is coming from because of the location. It does give a good view of the winds for Alaska, but we're in a bunch of trees. It shows the direction that highs and lows blow, so we know that a high pressure system rotates clockwise and a low pressure system blows counterclockwise. There is a low in the Gulf of Alaska. And I notice with our trails going in and out, when there's a lot of high winds, our trails blow over and it's really hard to travel between our cabin and Nenana. Water vapor imagery. Water vapor satellite pictures indicate how much moisture is present in the upper atmosphere, approximately from 15,000 feet to 30,000 feet. The highest humidities will be the whitest areas, while dry regions will be dark. Water vapor imagery is useful for indicating where heavy rain is possible. Thunderstorms can also erupt under the high pressure plumes. This slide is visible imagery. Visible satellite pictures can only be viewed during the day since clouds reflect the light from the sun. On these images, clouds show up as white, the ground is normally gray, and water is dark. In the winter, snow-covered ground will be white, which can make distinguishing clouds more difficult. To help differentiate between clouds and snows, looping pictures can be helpful. Clouds will move while the snow won't. Snow-covered ground can also be hard to find rivers. A lot of times the rivers are frozen here in the winter. And this satellite is infrared imagery. Infrared satellite pictures show clouds in both day and night. Instead of using sunlight to reflect off the clouds are identified by satellite sensors that measure heat radiating off of them. The sensors also measure heat radiating off the surface of the Earth. Clouds will be colder than land and water, so they're easily identified. Infrared imagery is useful for determining thunderstorm intensity. Strong to severe thunderstorms will normally have very cold tops. Infrared imagery can also be used for identifying fog and low clouds. The fog product combines two different infrared channels to see fog and low clouds at night.